Okay, so in 5.8, this is going to be the last section, this unit. We're going to create equations and inequalities in one variable, and then we're going to use them to solve problems. So there's lots of applications for quadratics, and that's what we're going to focus on, are all quadratic functions. But some reason, here's a picture of the arch. So we might want to find the maximum or minimum value. Notice if I want the value, that's actually going to be the y value, okay? And it's going to be of the vertex. We might also want to find out when a ball or a rocket or an object hits the ground. So if something hits the ground, it means its height is 0, which the height is typically the function that you're given. So you're going to set the equation equal to 0, okay? We might also want to know how long it takes to maximize profit or maximize something else. And so that's going to be our vertex. But if we want to know how long something takes, that's typically the time. And so that's going to be the x value. How long a ball will be in the air. So if something's in the air, you can think of it as I might throw it up and I might come back down. So we want to know the intercepts, which is when your equation equals 0. We might want to know a break-even point. So we want to set the system equal to each other and lots more, okay? So parabolas, they do really model a lot of situations in economics and just motion, things like that. So we actually use it. So I have a few different examples. So on example number 1, it says we're selling candy bars for a school fundraiser, and we're talking about profit. It's given by this equation. So P is for profit, where X is the number of candy bars sold, okay? So as I go down, since X is the number of candy bars sold, and then P is profit, we're going to make up our own graph, okay? So we're not going to sell negative candy bars. So I'm actually just going to make this my first quadrant. So this is going to be 0, 0, okay? So we want to label our axis, which I just did, profit, and we're going to say money, and we'll figure out what kind of answers we get in order to maximize this. And we don't have to go up by ones, but we'll decide that based on some values that we're given. So to label the axis, well, what I notice is we can go ahead and we can type this in. So I get negative 0.3, and I'm just going to go to Desmos. Goes negative 0.3, parenthesis x minus 50, and I think it was x plus 8. X plus 8. All right, and so I'm going to make this smaller. All right, and so that's what we notice. So I know I'm going to cross the axis at 50. Oops, sorry, I want to move. There we go. And I know I have a vertex. So notice we're going to go pretty large. We want to go past 200. So on my graph, I know I want to go to 50. So I'm going to make each of these 5. So 5, 10, and as long as you label a couple, it's okay. So 5, 10, 15, 20, 25, 30, 35, 40, 45. I'm just going to say 50. And then, because I know that that's important. But you want to use the same increment on each axis. So on the x-axis, I went by 5s every single time, so it's valid. I know I need to go up to 300, so what if we went by 20s? So 20, and I'll just say that. 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. And then 20, 40, 60, 80, 300. So I just picked every 20 dollars because it's in dollars. So it says, how many items do we need to maximize the profit? So I know, based on my graph, I've got, 50. And we're going to go back to Desmos. And I want the maximum. So I'm going to highlight over it. Oops. So I get 21,252.3. All right, 21,252.3. So 21,252.3, and that's my max. Okay, so here's 20, and we want to go to 250. So 220, 40, that's 60, so it's about right here. And it's not on the graph, like it's not on one of the lines. And then we're gonna I know it goes down to here, and then go back to my graph. I know it crossed right there at 0, 120. So at 0, 120, okay? So how many items do we need to sell in order to maximize the profit? So that was my maximum at 21,252.3, which is really like $252.30. So we need 21 items. The maximum profit is the Y value, so 252.30. Okay. What do the x-intercepts represent? Well, what would it be if I set my p equal to 0? Because that x-intercept means that y equals 0, which y is really p of x equals 0. So what would it mean if I set that equal to 0? Well, that's where I make $0 profit. Okay. And there's lots of reasons why you would make no profit. There's operating costs, cost of materials, cost of employees to package things up. There's a lot of reasons. So don't think, well, that doesn't make sense. How can you sell candy and not make a profit? Well, at some point, there are some things that they just have other operating costs that affect that. Okay. All right. Especially if we say that it's modeled by a quadratic equation, okay? If it's a linear equation, then no, that you're right. That's not possible. But, all right, let's look at my second example. The equation h equals, and if that bothers you, you can let this be y. Y equals 40x minus 16x squared. So when you go to type that into Desmos, you're going to want to use x and y, not h and t. It doesn't recognize what that is. So h is the height and in feet of a ball that's thrown straight up as a function of time, t in seconds. So we're talking about seconds and feet that the ball is meant in the air. At what time does the ball reach its maximum height? So I'm going to type that in. We've got 40x minus 16x squared. So let's move this over. Hold on. There we go. So 40x minus 16x squared. Okay. And so I'm going to go and I changed my scale, so I'm going to make this larger. I don't want to go all the way up to 80. Just have to move it. Oh, it actually goes pretty large. So I'm looking right here. So what they want is, I know that crosses at 2.50. I'm just going to draw it here so I have it. So I've got 2.5, and then I know it went like this. And let's see, that point is at 1.2525. So 1.2525. This is considered your work, okay? So it says, at what time does the ball reach its maximum height? So since they want the time, that's the x value, because that's the when. So we reach our height at 1.25 seconds. And the maximum height is the y value. That is the maximum. So we've got 25 feet. Okay. So if you show me a picture of the graph as your work, that really does count. All right. But we were really just trying to find the vertex. You can do this algebraically using other strategies. Number 3. So this is going to combine Unit 4 and Unit 5 together, but Desmos will definitely help you. So let's see, a model of the daily profits. We've got price per gallon, and we're talking about profit. So let's go ahead, and I've got negative 15,000. I'm going to type it into Desmos. These are really, really large numbers. So negative 15,000 x squared. Remember to use x. And then we've got plus 34,500x plus 34,500x. And then minus 16,800. Minus 16,800. So we are going to want to go ahead and change our scale. So we can go over, let me show you. We're going to go over here, and I'm just going to make, because that's really large, I'm just going to go up by 500s, and then we'll see. And my y-axis, let's just leave that. Oops, why didn't that do it? So it's not registering. Oh, yeah, I'm not sure why. Usually it just does it. Okay, well, it's not. Usually that would change it, but, oh, there's 500. That's why. Oh, because I want it on the y. So I don't want that there. I want the y-axis to go up by 500s. Oh, there we go. So, okay, where did my equation go? It's not showing it. Negative 15,000. Let's go up by thousands. So we're going to go 1,000. Oh, but I don't want the x-axis. So I'm going to do this. I'm going to go by 5s. It's got them reversed. Okay, so I just went ahead and started back over again. So here is my graph, and we've got, we want our y value, which is going to be really, 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 really large. Now, what I can do is I can take all of those numbers and divide it by 100. Okay, so what I did do was I changed this y label to 20,000, and I made my step to go every 1,000 on the y-axis. So this does look a little bit better. And so what we see is here's 0, 0. So I knew my parabola would open, and I know that maximum is at that 1.15, 3037.5. So 1.15, I'm going to write that down. 3037.5. And it's really skinny. Okay. Where do we cross? So we cross at 1.60 and 0.70. So 1.6 and then 0.7 is my other one. Okay, so let's go ahead and look at our questions. So it says, find the price that will maximize the profits. So this is our maximum. So it looks $1.15. Our profit is $3,037.50. What are the prices that would create a profit of $2,000 per day? So what we want to do is we want to set it equal to 2,000, a second equation. So I'm going to say 2,000. Let me show you what I did. I equals, and then we're going to look at where they intersect. So I'm going to make this a little bit bigger. Okay. All right. So I'm looking for right there. So 1.413 and 0.887. So 1 point. It really is, since it's money, it's $1.41 and 89 cents. This one had two answers because we really wanted like 2,000 to go through it. Okay. What is the lowest price needed to break even? So I want to break even when we have like our profits and our cost. The only issue is we don't have a cost equation, so I just have the model of the daily profits. To break even, then I guess I want my profit to be equal 0. So we just said that that was at 0.70 cents. That means I don't make any profit, or 1.6, which is $1.60. So at those two prices, because my profit was equal to 0, I didn't make any profit. I just broke even. The money I was charged and the money I was making was the same. So example number 4, it says, suppose you are tossing an apple up to a friend on a 3rd-story balcony. The height of the apple is given by this. He catches it. How long does the apple take to reach your friend? So I'm throwing an apple up to my friend. After 2 seconds, the height of the apple is given by this. So that's the height of the apple. Your friend catches the apple just as it reaches the highest point. So he's catching it right here. How long does it take the apple to reach your friend? So that's the x value of the vertex. And at what height above the ground does your friend catch it? That's the y value of the vertex. So he caught apple at, and then let's go ahead and plug this in. So negative 16x squared We're going to change the y values. We want to go back to the normal step. So we'll just make this like 30. Okay, negative 16x squared plus 38.4x. So plus 38.4x. And then plus 0.96. So plus 0.96. Let me just double check. Yep. All right. So that's my equation. Here's my graph, and I'm just going to go ahead. And it's really, really tiny. So I'm going to go ahead and just, that's because of my scale. So I want to know the highest point. So it finds it. 1.224. So 1.224. So at 1.2 seconds at 24, probably feet. Yep, feet. Okay. All right, so I give you very similar ones. Some are multiple choice. Try to show some work. I give you 5 to pick from, and I want you to try 3 of them. Okay, so good luck, and use Desmos. Draw what you have, just like I've done, and answer the question. Okay, good luck.